Hey, what's up, guys? Let's move this camera a little bit. Hey, what's up, guys? It's Mr. Miasis here. I wanted to do another video with you about two proportion z-tests. Now, I wanted to give you another example here because in my last video, man, you guys are shaking. Let's shake the screen. Sorry. In my last video, I did a problem here where I was talking about Super Bowl, and I used the pooled proportion. And what I didn't mention was when we would want to use a pooled proportion, why we would want to use a pooled proportion, and when maybe we don't really have to. So we don't have to use a pooled proportion if our two samples come from different populations. Now, if they came from the same population, like let's say we were doing males and females in the U.S. The U.S. is our population. Since I took those two samples from the same population, I would want to find the pooled proportion and use the pooled proportion in my hypothesis test. Let me give you an example here where we would maybe not need to use the pooled proportion, and I'll show you how that comes out. So let's take a look at another example of a two-prop z-test. Shrink myself. Come on. Shrink. Shrink. All right, here we go. So in a recent study by the Association of Mythical Creatures, this is a real place, I think. No, I'm just kidding. They surveyed a random sample of 551 vampires, 482 werewolves, and they were asked if they were evil or good. You know, because we got some good vampires out there, got some good werewolves, right? But a lot of them are evil. So of those surveyed, 328 of the vampires replied that they considered themselves evil, while 253 of the werewolves considered themselves to be evil. So, is there evidence that the percentage of vampires that consider themselves evil is significantly higher than the percentage of werewolves that consider themselves evil? And what would be that difference in proportion of evil werewolves and vampires? So let's go and take a look at this totally realistic hypothesis test. So here's what I'm going to do, guys. I'm going to, and for those of you that love, love what is that? Underworld. That's what I think of when you have vampires fighting werewolves. But some of those people that like, they like reading Twilight. They probably think of Twilight. Anyway, my null hypothesis here is going to be that the proportion of vampires is equal to the proportion of werewolves in terms of the proportion that believe they're evil. Basically, there's no difference, right? No difference between the two. My alternative is that there is a difference. In fact, that vampires are significantly more evil in terms of their proportion than werewolves. So I'm okay with just putting in the subscripts of V and W. It's clear that I'm talking about the proportion of vampires, the proportion of werewolves. What you don't want to do, don't want to put a hat there. We don't have hats on these guys, all right? These aren't samples. We're talking about the population. All right, we're going to want to do our conditions. So let's go and write our conditions out, and we'll try to speed up the conditions. All right, one, these are the samples are randomly selected. I can't write. I'm too scared of that vampire over there. Two, we'll assume that 551 vampires and 482 werewolves are less than 10% of all vampires and werewolves. I was going to spell werewolves. Like, I don't know, where are they? Where are the wolves? Not that type of werewolf, right? Where are the wolves? Okay, so our third condition is that we don't have any vampires that are also werewolves, and werewolves that are also vampires. That might be true in some lore, but we're not going to consider that. So in our survey, both groups are independent. And then finally, we're going to need to do NP and Q for each of these. So I'm going to write to the side here just so I have this as I scroll down. XV is 328. NV is 551. XW 253. NW is 42. NWO. New World Order. Okay, so N V P hat V is going to be the number of vampires that said that they believe that they are evil. They're evil vampires, so that's 328, which is clearly greater than or equal to 10. NVQ hat V is the number of vampires that said they were good, I guess. So that's 551 minus 328. Let me pop my calculator here. So tell me 551. 551 minus 328. Calculator. Nspire says, what is it? 233. Okay. Oh, 223. 223. All right. So then we're going to do the number of werewolves that said that they are good, which is 253. Greater than or equal to 10, and then the number of werewolves that said, I guess they were Alexa, what's 482 minus 253? It's 229. All right, 229. That didn't really sound like Alexa, right? I gotta get a better Alexa. Okay, so we've got our conditions done. Now we're gonna use a two-prop z-test. Now, I would recommend always stating what test you're going to use, especially if you're in AP statistics. You want to tell the AP readers, hey, this is the test I'm using. So that way you can get the credit for that. All right, the next part is we're going to do our mechanics. So we got to do some math. This is a math class, right? So we got to do a little bit of math here. Now, remember that I said that we use the pooled proportion when our samples come from the same population. I'm going to go ahead and consider vampires and werewolves different populations. I guess if you could say that they're all mythical creatures, like they're all mythical creatures because we said, you know, it's the association of mythical creatures. You know, I guess we could say that they're all mythical creatures, so I could pull them. But in this case, you know, really in this case, I don't think it matters. Let's just say they come from different populations. One sample came from werewolves, one sample came from vampires. Different populations, I don't really need the pooled proportion. So here's what I'm going to do. I'm going to find my z-score. And my z-score is going to be PV hat minus PW hat minus my hypothesized value. So it's always my statistical value minus my hypothesized value. Since I could write this as PV minus PW equals 0, P hat V minus PW hat, that's my statistic value. My hypothesized value, which is my null hypothesis for my population, this is the difference between the two proportions, which is 0. So this is going to be minus 0. Now, I don't really need that, minus 0. So normally, it's just going to look like this. Times the square root of P hat V times Q hat V over NV plus P hat W, Q hat W, over NW. Oh, NWO. All right, so let's go ahead and fill this in with all the proportions that I have. Now, P hat V, we're going to calculate P hat V by taking XV, which is 328, the number of vampires that said they were evil, divided by the total number, and we're going to get 0.595. And we're going to get P hat W by doing the same thing for the werewolves. So 253 divided by 482. And that's going to give us 0.525. Okay. So let's go and plug in everything in this formula. So TV Magic, Video Magic, I plugged in everything into the formula. And I'm going to go ahead and plug this in my calculator. So I got my TI Nspire here. And I'm going to do this button here so that I have my fraction. And I'm going to do 0.595 minus 0.525. And then I'm going to go down to the little box here, and I'm going to use my square root. So control square root. I like using that fraction. Oops, come on, man. That's not what I wanted. This one. Okay, fraction 0.595 times 0.405 over 551 plus, we'll use my fraction again, 0.525 times 0.475. I know this is exciting stuff, but I did want to show you how I enter it in my calculator. Enter 2.23. So we're going to say this is 2.23. With a z-score, I'm going to leave it as 2 decimal places because that's how we're going to look it up in the table anyway. So then we want our p-value. Our p-value. All right, we want to make sure we show our p-value here. Our p-value is z greater than 2.23. All right, so how do we figure that out? We use normal CDF. Normal CDF. So we're going to normal CDF that bad boy. Or you can use your z table, and you can find it on your z table. Okay, so my lower bound is going to be 2.23, and my upper bound is 99999. 0.0129. 0.0129. Okay, so there's my p-value. Now, let me show you how I do this using the TI Nspire and its 2-prop z-test, because you'll see that when I use that, my p-value is going to be very close, even though they automatically pool their proportions. So let me show you this guy here. Menu, statistics, stat test, 2-prop z-test. That's what I want. My x1 I wrote was 328. Tab 551. Tab 253. Tab 482. My hypothesis is that P1 is greater than P2. Bada boom. What do we got here? We got that. Whoa, what's it doing? What's it doing, man? We got that the p-value is 0.011. So it's pretty close. And my z-score is 2.27. So it's very close because they use a pooled proportion. You can tell they use the pooled proportion because they say p hat is 0.562. That's the pooled proportion. I didn't really need to use the pooled proportion. As you see, I'm going to reject the null. I'm still rejecting the null, right? I'm still rejecting the null because this is smaller than 0.05. Was I given? I wasn't really given a alpha level, but if we say our alpha level is 0.05, that's clearly enough to reject the null. So there is evidence the proportion of evil vampires is higher or greater than the proportion of evil werewolves. Werewolves? Where? Werewolves? Okay, so we can do that with our confidence, with our hypothesis. Now, let's say, and notice, and let's get our confidence interval. It says estimate the difference using a 95% confidence interval. So let's go ahead and do the confidence interval. Now, we learned in another video that the confidence interval is going to be PV hat. Let's put confidence interval here. PV hat minus PW hat plus or minus Z star. In this case, that's 1.96, right? Z star, because we're doing 95% confidence, times the square root of PV hat, QV hat over NV plus PW hat, QW hat over NW. So what I'm going to do is put this stuff in. So let me put that in here real quick. Put this in my confidence interval. I'm going to go ahead and use my calculator here. I'm going to use 2 prop Z interval. Still want to show my work, especially if I'm in an AP class. So let me scroll back up here to see what my X's were. Okay, so my X1 is 328, 551, 253, and 42. 482. 95%. Give me it, give me it, give me it. What's it say? Oh, what are you doing? What happened, computer? Where's my stuff? Where's my stuff? Didn't do it. Didn't do it. Let's try it again. Statistics, confidence intervals, 2 prop Z interval, 328, 551, 253, 482. Come on, man. There we go. All right, so we've got 0.0098 and 0.13. 0.0098 and 0.13. 0.0098 and 0.13. So what's this tell us? This tells us that we are 95% confident that the true proportion of evil vampires is between, oh, that's a mighty small lower. Okay, well that's what it says. So we're gonna go point. Let's see, what percent is this? 10%. So it's gonna be 0.98%. 0.98% is between 0.98% and 13% higher than the proportion of evil werewolves. All right, guys, so there you go. We've talked about 2 prop Z test. I've done a problem with 2 prop Z test and a 2 prop Z interval. I put them together. I showed you the conclusion. We used one that we did not need to pull the proportions, and we took a long time doing it. Sorry, but this was a big video for a lot of stuff, and I hope you learned something about vampires and werewolves. Talk to you soon. Later, guys. Bye.